Am I audible? Hello. Okay. Let me wait. Okay. So let me start. Let's see. Let's see. Okay. Is it visible?
Yes.
Okay. Okay. So today first we will discuss the assignment question. Do you have solved the question? The assignment question?
For which week?
First week. Because the deadline of first week is over. So now we can discuss.
Yes.
Okay. Okay. So first we'll discuss those questions. Then after that we'll discuss the question related the lectures from the last week. Okay. Okay. So let me off. So that's not needed. Okay. Now. Okay. So we can also give the answers because these questions are not that much difficult. I saw the question, but I did not solve. I thought that I should solve live in the live class. Okay. So first we will discuss the assignment question. This one, I think. Okay. Mhm. One minute. Just a minute. So assignment one, week one. Okay. So first question, the energy of the system consisting of all of its independent molecules in the ground state is. So the energy of the system consisting all molecules, all independent molecules are in the ground state. What will be the energy?
0.
Why?
All are in ground state.
All are in ground state, but here you are considering that the ground state energy is zero. In that case only, but let's say in the case of let's say for simple harmonic oscillator or vibrational case, you know that for vibrational case that the ground state energy is zero, is called 0 point energy, that is not zero eventually. Okay, so
Yes.
if you consider the ground state energy, because when you are considering the molecules, independent molecules, and you have to calculate the energy, then obviously you have to consider all types of energy. You know that in case of internal energy, you have to consider all sorts of energy. It may be our rotational plus vibrational, translational, electronic, each and every energy you have to consider. Or there are all other types of energies as well, but in all cases you will see later that these are mainly four energies. All cases, what happens, this ground state energy that for rotational, translational, electronic, in each cases, the ground state energy is zero, except vibrational. In case of vibrational, this ground state energy is actually not equals to zero, but we studied in the last class that we can uh, we can make a relative energy diagram for the vibrational energy level, considering the 0 point energy zero. In that case only, the ground state energy will be zero. But the general formula should be the energy should is joining. Yes. Okay. Okay. So in that case, the energy should be how many numbers of molecules? Uh, all molecules. So, okay, if the number of molecules is important, let's say there are number of molecules is n number of molecules is there, n into the 0 point energy. You have to write 0 point energy. This should be the answer. But I said that if you consider the 0 point energy as the zero, then it will be zero anyway. But the proper answer should be n into what will be the 0 point energy? What is 0 point energy? The value of 0 point
Half
energy?
h nu.
Half h or h cross omega. Both are correct. So it's actually we generally follow this notation h cross omega. Omega is angular velocity and nu is the frequency. So you know that. So you can convert, and h cross is h by 2 pi. So both are correct. So this will be the total energy. Okay, for the if the all molecules reside in the ground state. So you have to keep in mind that it's not zero. It will be zero if you consider this 0 point energy is zero. Otherwise, you have to consider the 0 point energy. Okay,
So what is the actual answer?
this should be actual answer.
If it is in the exam, then what is the answer?
Then you have to follow the options. Okay, it should not be zero and n by 2 h cross omega. Both options should not be there. Okay,
In the assignment, there was no option.
there was no option, and I saw that the answer was given zero. So that means they have considered the 0 point energy. Again, anyone join? They have considered the 0 point energy as zero. And also, in general, okay, it better to discuss. If you gone through the lecture videos, then you might seen that in the lecture videos, the internal energy U is considered that U0 plus E, something like this, right?
Yes.
But actually, we considered the average of energy is actually the internal energy. This also be considered, okay, because what this notation has considered, because this u0 is coming from the 0 point energy term, that also has been discussed, this perspective. But if you consider the 0 point energy while considering the vibrational energy level, there are two ways. while calculating the vibrational partition function or vibrational energy distribution, if you consider the 0 point energy, then you directly follow this abbreviation. This is perfect formula. Nothing is wrong there. Internal energy should be the average of E. But in that E, the vibrational energy level should be considered as should consider the 0 point energy in the vibrational energy level. We should not consider the relative distribution. Last day I saw the relative distribution and the original distribution. So original distribution you have to follow. But if you follow the relative distribution, considering the 0 point energy is zero, then essentially you have to add that 0 point energy later as U0. Okay, so you can follow both. Nothing is wrong. Okay. So that's why I'm saying here, if 0 point energy is considered, then obviously, but if you ask me, then I will say this should be followed. This is more, uh, I think, straightforward. That internal energy should be the
Without
average of,
considering 0 point energy.
yes, in vibrational, because you saw yesterday that in last class that Q for vibrational partition function, what is the difference? This was the difference, right? H nu by kBT. This is the
Yes.
relative. And for original, there was one more term in a numerator like this, if I'm not wrong. So it's better to consider something like this, right? So you better to consider this. If you consider this one, this partition function, then you will get directly this energy. But this is approximated, obviously, because you are considering the relative distribution. I agree that overall result should be very much similar, but this is original, this is approximated. When you are considering this, you have to consider this 0 point energy separately later. In that case, you have to consider the daily is of the internal energy should be the average of energies, because in this in average of energy you have not considered the 0 point energy. You have to account that 0 point energy separately. So that's why you have to add that u0. Otherwise,
May I ask one question, please?
yes, yes, yes.
Is it only available at a higher temperature, the vibrational mode?
No, not like that.
In lower temperature, it is also important.
Available, yes. If you look at the energy gaps between the energy levels, rotational energy gaps are smaller than vibrational. Okay, translational is much smaller. Translational, rotational, vibrational, then electronics. Okay, so first translational energy levels will be filled, then the rotational, then vibrational. That's why in our thermal room temperature, because in room temperature there is only thermal energy, heat is there. So that's why in rotation in room temperature, the translation energy levels are basically occupied. And you will see later that when you study the spectroscopy, that as the in energy gap between the translation energy level is very less, this can be occur very similar. Let's say I want to say for rotational case or vibrational case, the energy gap will be like this approximately, just not to scale. But these transition are actually, there are two types of transition, radiative and non-radiative. So this transition, when one molecule comes from this energy level to that energy level, the transition, the energy will emitted as radiation. So it is a radiative transition. Okay, but in translational case, the transitions are between two energy levels, because you see these energy levels are very close to each other. So these transitions are essentially non-radiative. Means what? When this transition occurs, photon emitted H nu. But in this case, photon does not emitted. This is non-radiative. So in that case, the heat is emitting. Okay, the kinetic energy of molecules will be increased or decreased. So there are two types of transition. So that's why translation energy levels are associated with non-radiative transition, and vibrational, electronic, rotational, these are radiative. So only when you are when you heating something, then the vice versa. When you heating something, you are providing the thermal energy. That thermal energy only can give that excitation in these energy levels, translation energy levels. But to make particle or molecules excited in rotational or vibrational state, for that you need radiative transition. You have to give photon. You have to give the lights for particular frequency. In fact, spectroscopy, that's why we have to give the radiation of particular frequency which corresponding those energy gap. Okay, so This is not like that. You have studied that when if you decrease the temperature, let's say when it's very close to 0 point energy, sorry, absolute temperature minus 293 273 Kelvin means degree centigrade, 0 Kelvin. In that case, only all molecules resides at the ground state, right? That's why rotational energy will be zero, translation energy will be zero, electronic energy will be zero, everything will be zero. But in vibrational ground state, there is energy. 0 point energy is there. That's why there will be energy. Okay. The energy,
Okay.
internal energy will not be zero. That you studied now that there is entropy in last week. S equals to
Yes.
KBL and W or omega. From where it is coming? It is eventually T tends to T tends to 0 Kelvin. Okay. So that's why at T tends to 0 Kelvin, only vibrational energy levels are there. That's why only Q vibrational was considered. If you remember, only Q vibrational was considered, and from that you derive
Yes.
this. So this contribution is purely coming from the vibrational distribution, because other are zero, na. So only vibrational state will be there, and that entropy is called residual entropy. Okay, I will discuss later this residual entropy, because this entropy is coming due to the presence of that molecule. When at absolute zero, these things should be visualized. At absolute 0 Kelvin temperature, what I'm saying, rotational energy is zero, because in rotational state, the molecule or particle is residing at the ground state, and the ground energy of the ground rotational state is zero, ER, let's say, or E0. This will be zero. That means, what does it mean physically? What does it mean? Rotational energy is zero means molecule is not rotating. That's it.
Yes.
If a molecule is rotating, for monoatomic, let's say consider that diatomic, it is rotating means it can rotate. That's why I'm not saying, because when you study the rotational partition function or rotational spectroscopy, I should say rotational spectroscopy, in that case, you will study that due to rotation of a molecule, this quantization of in energy level appears. Okay, so when this is the ground state, J equal to zero, J is rotational quantum number. That means the molecule is not rotating. Simply, molecule is residing at a fixed position. It's not rotating. Similarly, electronic energy is zero. That means there is no electronic transition. Elect in benzene, you saw na? This is a electronic level. There are lots of electronic level, right? Another one is this, or this maybe goes there. These are all electronic level. But in when absolute zero is approaching, temperature is approaching to absolute zero, electronic excitation are not there as well. That is, the molecule will be deciding at the electronic ground state. For that also E0 will be zero. Only vibrational is zero, non-zero. That means vibration you can't stop. You can't
The
stop the
entropy is not
vibration.
zero
Yes, entropy is not zero. You can't make
at zero Kelvin.
entropy will be zero for perfectly crystalline solid.
Yes.
Okay, that is only one possibility. Otherwise, it will be non-zero. I'll discuss the residual entropy in that question. I will discuss this part. Okay, in
Okay.
detail I will discuss. Okay, so this was the question number one. Someone joined. Something happened. 1 minute. Let me check. Okay, so okay. So now question number two. For a system consisting of 20 independent molecules, the weight of the configuration W that is given. Now ln W can be written as LNW you have to calculate, right? But this formula is something given Ni sum over Ni dni. Sum over I Ni dni. Okay. So 20 independent molecules are there. So what will be the weight of configuration? But sum over Ni n is not given. LNW
20.
no 20 is the molecule. Number of independent molecules are 20 and the weight of configuration is W, but you know how to calculate W, right? How to calculate W? That n factorial divided by pi over Ni factorial. This is the formula of W. Okay. So now we have to calculate the LNW. What will be the LNW? You can write ln n factorial minus ln of pi over Ni factorial. Okay. So now here we can apply the formula Starling approximation that ln x factorial equal to x ln x minus x.
Yes.
So it will be n ln n minus n. And you see here that this is actually ln. So when you operate ln on the pi machine, it will give us summation. Okay, is it clear?
Okay.
Correct. Because this is pi means, let's say, consider a case ln. Uh, this means what? Ni factorial means n1 factorial, n2 factorial, n3 factorial. If there are only three steps, this will be the case. So this means what? N1 factorial. N1 factorial means you have to calculate n1 to 1. All will be there. So it will be ln n1 into n1 minus 1 into n1 minus 2 and so on. Okay. Then it will be again n2 minus 1 up to 3 to 1. It will be n2 minus 1, n2 minus 2, again 3 to 1. Yes, only 2 are there. So when you operate ln, you know ln AB equals to ln A plus ln B. So if you apply this, it will be ln1 plus ln n1 plus ln n2 or ln n1 minus 1 plus ln n1 minus 2 and it goes on. Here
Summation.
summation, but same will be there for n2 as well. So like this, n2 minus 2. Okay. So if you may, how you can sum this will be n factorial, ln n factorial. Wait. Okay, you can do it, but before that, this is understandable.
Yes.
Okay. So now we can also apply here to make it more clear. You can do it like this. Do it. You can do it. This is correct. Ni ln ni minus ni. It is 1 minute. If you apply this formula x factorial, okay, this will be okay. You can write it.
Yes.
Hmm. So it will be ln n ln n minus n minus over I ni ln ni, and this is essentially the capital N. Sum over ni
Yes.
is capital N, so it will be cancel out. So it will be n ln n minus I ni ln ni. So you have to calculate. For that we have to know the ni. That is not given here. That should be, otherwise, I think probably they want to ask this part. That's why there is a minus something is given. I don't know. If you look at the question, there is some over NI, DNI is there.
Yes.
So probably you have to consider this part only. Let me check the answer. LN20. Yes. Yes. So they want to ask this value. So the in question they want to ask LNW. LNW can be written. Okay, LNW can be written as, question was LNW can be written as blank space minus sum over I NI DNI types. This is asked. Okay. As this is
Yes.
asked, that, so this should be not DNI, this should be LNI, right? This should not be DNI. It should not be DNI. Probably there is a typo. So the answer will be NLN. So you have to calculate this NLN. What is N? 20. LN 20. So it will be 20 into 2.995. So it's approximately 60. This is given as answer. Okay. Is it okay?
Yes.
You see, there is no derivative. Unless you make a derivative, how the DNI will come? So DNI should not be there.
DLNW. So why there is no derivative?
No, they did not ask the derivative, right? They asked only the LNW. So you
Okay.
know the formula of W. So now you have to just take log. So how the
Yes.
D will come? So in the question, NI DNI is written, but probably that should not be DNI. That should be LNNI. Probably the typo is there. They thought ln something like D, because who make the question, he does not type. He type
Yes.
question types something. That's why probably this typo is there. Okay. Question number 3. For a system with 5 equally spaced, so equally spaced, non-degenerate energy levels. Okay. The population that t tends to infinity is given by, given by pi equals to e to the power beta epsilon I divided by what? This is asked. Okay, we have to identify the value of this blank space or the question mark. Okay,
5.
how?
Because at infinite temperature, all gets same amount of molecule, all energy state. So 1 by 5 in all.
1 by 5 in all? 1 by, okay, you directly did that. Okay, but you apply, what formula you apply? This.
Ni over capital N.
This is equals to this. This does not mean that this is Q actually. This does not mean that N equals to Q.
Oh,
Do you get it? This should be
yes.
minus. Again, there is a typo. Minus should be there, right? In Cartesian
Yes.
function, minus should be there. So how you can calculate this Q?
1 plus e to the power minus beta epsilon 1
Sum
plus.
over j e to the power minus beta epsilon j. And there is
Yes.
no degeneracy, so gj equals to 1 for all, so we can ignore that. Okay, so at infinity, when t tends to infinite, then beta tends to essentially 0. So what it will be, e to the power
Zero.
Means 1.
Yes.
That's why it's coming that number of energy levels. Okay, means you can write it e to the power minus beta epsilon 0 plus e to the power minus beta epsilon 1 plus e to the power beta epsilon 2 and so on.
Yes.
There are only 5 levels, so 5 will be there, 3 and 4 because you are starting from 0. So 5 energy levels are there. If you draw it, 0, 1, 2, 3, 4, 5 energy levels are there. For all cases, beta is 0, beta is 0, beta is 0. So if you put beta 0, then all gives 1. So that's why it's coming directly 5. It matches with q equals to n. Otherwise, it will not. Okay. If it is not t tends to 0, you can't directly write that n equals to q, or as you said, you are correct. Both are correct. Pi can be defined like this. Both formulas are right, but they are asked in this form. So it will be 5 in this case. Let's say if t tends to 0, then how you can write it? What will be the answer when t tends to 0? Instead of t tends to infinity, if it is t tends to 0,
Q is 1 then.
q will be 1
1.
because only the
First excited state.
first term will be survived. Because when
Yes.
t
All are
tends,
in first state.
all are in first state, when t tends to 0, beta tends to infinite. So if beta tends to infinite, every terms will be 0. Why this will survive? Because epsilon 0 is 0. Again, you have to consider the ground state energy is 0. Otherwise, not. If you consider the ground state energy is 0, then only q will be the 1. Okay. So in that case, q will be
Okay.
1. So, but in this question, the answer should be 5.
And why this is 1? May I know?
1 means when t tends to 0.
Yes. Infinite into 0. So it's indeterminate.
No, 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 not like that. It is beta by epsilon 0. If you when epsilon is 0 eventually, then you have to consider that epsilon minus 0, so it is 1. So okay, you are right, but not like it's not like that. Infinite into 0 is undetermined. This is not correct. Okay. Uh, Beta, you can think like that. You have to expand the series. You know the e to the power x series. So if you
Yes.
expand the e to the power minus x series, from that series you have to put the value of beta and epsilon 0. So when epsilon 0 is 0, this beta will be irrelevant. The value of beta will not be considered, because when you are considering the beta, it's, let's say epsilon 0 is not 0. In that case also it is not uh, infinite. It's not infinite. Beta is not infinite, means the infinite has a value. I want to mean that it may be 10 to the power 5, let's say, maybe 10 to the power 5, but when you multiply it with 0, then what will get 0 na. So
Okay.
infinite into 0 will be 0, not in undetermined or something. Is it clear?
Yes.
Because infinite may be huge, 10 to the power 100, but when you multiply that with 0, it will essentially gives a 0 value. So
Yes, but
that's why,
there as in calculus it is indeterminate. So I was thinking.
no, when it is 1 by 0 is undetermined, that is not infinite. So there is a difference between 1 by 0 and infinite. Let's say x equals, let's say 1 by x, y equals to 1 by x. When x is approaches 0, y approaches to infinite. But when
Yes.
x is 0, y is undetermined. Both things are different. Okay.
Yes.
In that case, x is approaching 0. That is the limitation of, you can say, mathematics till now. Then you have to consider the near, that is called neighborhood type things, because x is tends to 0. When x is absolute 0, y will be, means if you plot it, when x is absolute 0, y will be undetermined. There will be no value. Otherwise, it is going infinite. So like this.
Yes.
Okay. So these two things are different. So here it is approaches to infinite, not the undetermined. So infinite into 0, that is 1. No. When you have undetermined into 0, then you can think. Then your argument may be valid. then it should be 1. Okay. Means y equals to 1 by x, and you multiply it with that x, xy, and x tends to x equals to 0, then it will be 1.
Yes.
But that does not mean that infinite into 0 is 1. That is not true. Okay.
Okay.
Because infinite is a number. Always you have to keep in mind.
Yes. It's tending to infinity.
Yes, it's maybe huge number, but it's still a number. So it will
Yes.
be
And multiplied by 0.
0, it will be 0. Okay. So now question number 4. The value of partition function of a system. This is the same question. Wait, I can say system at t tends to infinity is, okay. What will be the answer?
1.
No, t tends to infinity.
Oh, sorry. 0.
0. How?
E to the power negative infinity. No, no. 1 minute. 0. It's not 1.
No, t tends to infinity. So beta tends to.
0.
So if you put beta 0, then e to the power minus 0 is 1.
Yes.
So this should be answer, na?
Oh, there is. Yes.
If there is no
Degeneracy.
degeneracy, then it will be just number of energy levels. Just number of energy level, right? In the last case you saw, na? There was no degeneracy. That's why it comes just energy level, number of energy levels. So it will be Qj. So essentially, for vibration, any case, it should be infinity. Why? Because there is no upper bound of energy level. If you consider vibrational, rotational, any electronic, there is no upper bound. Okay. Energy level in vibrational, the energy level goes up to infinity.
No upper bound.
No upper bound. In rotational case also.
All can go to infinity.
Huh,
Translational protection.
exactly. All can. Rotational, vibrational, translational in all cases that goes up to infinity. This is for ideal case, obviously. For ideal case. In reality, this is not true. In reality, the harmonic oscillator is looking like this is an harmonic oscillator, and this is harmonic oscillator. Harmonic oscillator,
Yes.
this energy level will goes up to infinity, and all are equispaced. But here the spacing decreases like this, and here the after that the bond will break. That's why the bond breaks. If it is actually the infinite, then the bond will never break. So if you
Yes.
consider the simple harmonic oscillator model, the bond will never break. But this is actual picture is the anharmonic oscillator. So this is the bond dissociation energy. By if you give this amount of energy, the bond will break. Okay. So
Okay.
in practical, obviously, this does not go up to infinity. But we are considering obviously the our ideal cases, the simple harmonic oscillator or rotational energy. In all cases, this essentially goes up to infinity. Okay. So that's why the answer is infinite. For a system with two-fold degenerate ground state, and three-fold degenerate force excited state. if Kt or Kbt, should write Kbt, very less than epsilon, the value of Q is close to what? You can try this question. What will be the answer?
5.
Let's see. Q. Q means Gj
Gj e to the power minus beta j.
beta Ej. So only two levels are there. So let's say G0 e to the power minus beta epsilon 0 and G1 e to the power minus beta epsilon 1. Okay, so two energy levels. So ground state is E0, that is 0, and fast excited E1, that is epsilon. These are given. Epsilon is given, means the energy gap. So energy gap is given, so that means epsilon 1 should be epsilon. So if we put it, so it will be e to the power 0 means it 1, and it is G1 e to the power minus beta epsilon. G0 is, it is eventually, it is
2.
twofold degenerate, and this is threefold. So it is 2, and this is 3 e to the power minus beta epsilon, means epsilon by kt or kbt. Just you have to consider this. Now, what is given? That epsilon is very greater than kbt, right? So epsilon by
Yes.
kbt is very greater than
1.
1. So you can write it 3 by e to the power epsilon by kbt. So it is also very greater than 1.
Yes.
So, okay.
Yes.
So if this is the case, if you multiply it with 3, then also it should remain same. So it
Very,
is
very less than 1.
very less than 1. So you can consider this 2. Okay.
Okay.
Or you can directly do it by expanding this series, e to the power x series. What will be the e to the power x series? E to the power x or sin x or cos x. Do you know this series expansion?
Yes.
How you can how you do that? The series expansion, how you do that?
X to the power 0 by 0 factorial plus x to the power 1 by 1 factorial plus x square by 2 factorial.
Uh, uh, again, repeat it.
X to the power 0 by 0 factorial plus x to the power 1 by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial.
This means what? For
E to
which
the power
series?
x.
E to the power x. How do you know? Do you remember or you know to derive?
I forgot to derive, but I knew that.
Okay. Okay. So essentially there is a formula, not formula. Okay, let me say it. It's not that much difficult. You know the Taylor series?
No.
Okay, you don't know. Taylor series is, let's say, if fx is there, any function, okay, fx or x is there. So let's say you don't know the nature, it may be anything. The curve may be random curve. So if random curve is there, so any value, you know the value, let's say this is x equal to 0. Suppose this value is known and anybody asks you to calculate this value where x equals to x at this point. how you can calculate. Okay, so for that, Taylor gives this formula that if x equals to x, at x equal to x, this fx will be, you can calculate x equal to 0, f0 plus dfx dx at x equal to 0, or let's say it is x equal to a, any point. It may be any, I should write it generally. xfa, x equal to a into x minus a plus d2f x dx2 x equals to a x minus a square plus so on.
Oh,
Okay,
this is Taylor series. Okay, okay. I
this is this is the general formula for Taylor series. Now when you a may be 0, a can be any value, any point
yes.
that is known to you. So if it is 0, then directly you can write it fx equal to f0 plus dfx dx, or directly you can write f dash x or f dash 0 into x minus a will be x. Okay, one thing I miss. There will be 2 factorial, there will be 3 factorial, there will be 1 factorial. Factorial things will be there as well. So then it will be x square by 2 factorial into f double dash 0 plus x cube by 3 factorial and so on. Okay, this formula you can use. This is the general formula. Now, now let's say fx equal to e to the power x. Then e to the power x will be e to the power 0 plus x into e to the power, the derivative of e to the power 0 is,
One.
which means, no, no, no. This means
E
what?
to the
F
power
dash
zero means
x.
one.
F e to the power 0, let me say f dash x. F dash x means df
E to the
dx.
power x.
It will be e to the power x. So now e to the power x, it will be e to the power 0. X square by 2 factorial e to the power 0. X cube by 3 factorial e to the power 0. And so on. So it is actually 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Okay, this way you can get it. You can do it for sin x using this formula, easy. What will be for sin x? It will be sin 0 plus x into
Cos
what?
x.
Cos 0.
Yes,
So this
cos
will
zero.
be cos 0, and then it will be x square by 2 factorial. Again, it will be sin 0, but there will be a minus sign.
Yes,
Then x cube by 3 factorial
cos zero.
cos 0. What will be the sign?
First one is positive and then negative.
Negative, then positive. So it will be again minus. Okay. So then it will be x to the power 4 by 4 factorial sin 0. Then it will be x to the power 5, 5 factorial cos 0 and so on. So you can see here this all term will be 0 because sin 0 is
Yes,
0 and cos 0 is 1. So only that this term cos term will be survived. So it will be x minus x to the 3 factorial plus x to the power 5 by 5 factorial, then it will be x to the power 7 by 7 factorial plus x to the power 9 by 9 factorial, like this. Okay, in this way this series are come, these formulas are, that's why I generally don't remember the formulas, I forgot, but I know this Taylor series. From that Taylor series you can derive any series expansion. So here also you can use that. It's better to know. So in general the
all
formula should
expansion is from that.
all all expansion. This is excellent formula, this Taylor series. And when you put the x equal to 0, here you put na x equal to 0, so this series is called Maclaurin series. Just a reduced Taylor series, you can say this is. But actually, this is in general it is called Taylor series. So there was a YouTube video you can search. Taylor
Yes,
series in YouTube, and three blue one brown. There is a channel. So from
yes,
there
I
you
know.
can, yes, you can see this Taylor. You can visualize how this fits actually.
Yes, yes.
Right. So in general, you can write down the formula that f x equals to sum over dn fx dx to the power n at x equals to a x minus a to the power n divided by n factorial n's 0 to infinity. Okay, is
Okay.
is matches.
Yes,
So this formula you can remember. Okay. So now question number 6. The number of ways three indistinguishable molecules can be arranged. What will be the answer?
3 factorial,
Three factor. How?
indistinguishable,
Indistinguishable means?
cannot separate each.
Yes, you can't separate it. Three indistinguishable molecules are there. How many energy levels is that mentioned? How we can say 6? There are options 3, 6, 1, 2. Four options are there. An answer is given also 6. But you should know the energy levels. How you can say? If you don't know the energy levels, there may be two energy levels or three energy levels. Then you know the formulas m to the power n, or you know the m factorial divided by n factorial minus m minus n factorial. So for that you must know the number of energy levels.
3
Okay,
energy levels.
is that mentioned in the question?
We cannot place one molecule in one more than one in one state.
Why? That is true for Fermi particle only, fermions.
Yes.
If it is boson, then first of all, this is indistinguishable. So quantum mechanical particle means either it should be boson or fermion. Then also you have to mention the number of energy levels. Otherwise, but I think if there is no degeneracy, I discussed, if there is no degeneracy, the number of ways how we can arrange that should be only one. Let's say if there is three particles are there. For fermions, it should be one, yes. But that depends on the energy levels. I think this question is incomplete. For this, we have to need the number of energy levels.
Yes, I realize this should be one.
But for that only, that is for fermion you can say, but boson how you
Yes.
can say this also. So it's better to consider the number of energy levels. Otherwise, it will be just you can guess. If otherwise you can't give the proper answer. Probably something is missing. This question is not complete. I think as 6 is the answer. 6 means it's only the 3 factorial, right? Types things.
But
3
sir,
fact.
if
Yes.
it is indistinguishable, so it should be divided also by a 3 factorial. If it were distinguishable, then we should write only 3 factorial term. Means
If
like
let's say
in
let's say it is distinguishable.
uh-huh, uh-huh.
First, you complete. What are you saying?
No, that I was telling only that, like in mathematics on also, if we have to arrange three distinguishable balls or
Hmm.
indistinguishable anyone, so
Hmm.
there, if it was distinguishable, then we used n factorial. But
Yes.
if two of them were indistinguishable, of same color or of different color, then we have to divide it by that numbers also.
That numbers, but even it is distinguishable, it's not only the factorial.
Hmm.
It factorial is true for if on, in one state only one particle is there, then it will be n factorial.
But sir, if it is not given in any energy levels, by
It
default
is
we
not.
consider that there will be one. Otherwise, means by default we consider only the ground state if not the
Okay, let's
energy
say.
levels are done.
Okay, let's say there is only one ground state, and now
Hmm.
three particles are there.
Yes, sir.
Then how you can arrange? Then arrangement will be one only.
That I was telling. 3 factorial upon 3 factorial. If we do like that, then I will get
It
only
will
one way.
it will be only one. Just you can visualize if it is distinguishable even, then also it will be ABC or ACB or BCA, anything it may be, but all are the same because there is no other energy level. If there is also if it is degenerate also, then you can think. But if only one energy level, you know the formula, right? For the formula was
Hmm.
m to the power n
Hmm.
for distinguishable. And for
Yes,
in
sir.
indistinguishable case, you have to consider these formulas n factorial, m minus n factorial. Okay,
Hmm.
this is for when only in one state one particle is there. This is for in any state any particle can be there. Then it will be m to the power n. Let's say
Yes, sir.
if you have two particles, here three particles, and you have only two levels. Then for first energy level also there will be three options. For second energy level also there will be three options. So that it will become 3 square 9. So you need the number of energy levels.
Okay. Okay. So answer it was given 6. That
It
is
was
wrong
given
there.
seriously. I think the question is incomplete. Must be there. Should be energy level should be there. Then you can do it.
Okay, sir. Thank you.
Just here they should write in how many energy levels. Then it will be easier.
Okay.
But if it is indistinguishable and only you are considering ground state, obviously that will be one. Otherwise there is no option.
Hmm.
One possibility.
Okay, sir.
Okay. So now the weight of instantly, yes, the weight of instantaneous configuration 322. This is straightforward. What will be the W? Is n factorial divided by,
1 factorial into factorial into factorial.
yes, so it will be just what is n? 7. 3 plus 2 plus 2, which is 7 factorial by 3 factorial, 2 factorial, 2 factorial. So it will be 5, 4, 6, 7 by 4. So 30 into 7, 210, 220. This type of question you should not expect in the CSI net or gate. This much straightforward question will not be there. This is very much straightforward. Which of the following constraints applies for dominating configuration? Okay, dominating configuration that is given here. Ni and epsilon I represent, you know this. So, and the options are option A 0, Okay. So what will be the answer? For any configuration, what should be the answer? Ni is the number of particles in the ith energy level, population in ith energy level, and epsilon I is the energy of ith energy level. Then among
Second
four,
option.
exactly, second option. Because this should not be zero. The correct one is sum over Ni should be n, total number of particles. And this is and this should not, this is not true. This this can't be anywhere true. This means the internal
So why
energy
is
is,
it in answer?
what is that?
Why is it in answer? This is the answer. Summation Ni equals to 0.
This is the answer, correct answer. This
But B is correct answer.
B is correct answer. I'm saying this is the correct
Yes,
answer.
yes, but in the answer there is C, correct answer, and I'm getting 0 for that.
No, there is B is answer. This this is given an answer as well.
This is given.
Huh? As I can see here, this is given.
Okay.
Probably there must be any malfunction maybe there. Any, but here it is given as epsilon in I. This should not be. Anyway, it can't. This
Yes,
has
I was thinking also.
this has justification. When the heat is zero, then it will be zero. But this is in general. Question number 9. Okay. How many questions are there? Well, I have also some question to discuss. Okay. For the weight of a configuration W, choose the correct option. Okay. Options are one by the. So what will be the answer?
B.
Yes. This is also done in class. How you can do it? You know the W. W is
Yes.
n factorial divided by ni factorial.
In a,
Then you have to take log. Then you have to take just derivative. After taking log, the what will be the value? Ln, this we have already discussed. Here, ln minus this. When you take the derivative, this is ln w. So if you take the derivative of this dl and w, then this part will be 0 because capital E is constant eventually. So from here only you will get the derivative part and it will give the this one. Okay. Should I do this? This was done in class even.
okay, no need.
Hmm. This is straightforward. That Lagrangian indeterminate multiplier. Yes, alpha beta when he calculated the value of alpha and beta in that case. This was okay. Question number 10. Again, okay, for us, okay, this is a for a system consisting n independent molecules, choose the correct option. What should be the answer? This is also what will be the answer?
C.
Yes, you should not think this much. This is easy question because you know that. Let me change color. Ni sum over ni is capital N,
Yes.
and when you take the derivative dni, what will be? Some
0.
dn. Take the derivative with respect to. You have to take derivative with respect to something. Let's say w. W is the configuration. Then you can do it. And here one thing is that this is 0, but you have to know that derivative and summation commute. Okay, in integration you studied na, in differentiation derivative and summation commute. Let's say
Yes.
ddx equal to x plus x square plus x cube, anything, then it will be, you can write it dx dx plus x square dx, this way. That means you can break the sum. You can take the derivative out or in, that will commute with the summation. The language is the commute, so you can write it like this. So essentially somebody. Alright. So it is question number 10. Two more questions are there. We will discuss our question. Okay. For a two-level system, the population of the upper state at t tends to infinite, all okay, 0 and infinite, both you have to consider respectively are. Now the same type of question. 0 and the upper state, two-level system, 0 and epsilon. So when you have to consider the population,
When temperature is 0, all are in ground state. So in
all are
upper
in,
state there will be 0.
yes, so you can write it that population on Pj is Nj divided by capital N. So that means e to the power minus beta Ej divided by Q. Q is here, so e to the power minus beta epsilon J. So now when the temperature is 0, first case is, you are correct, temperature is 0, beta tends to infinite. So we have to calculate the P1, first excited state. So it is e to the power minus beta epsilon divided by 1 plus e to the power minus beta epsilon, and beta is going up to infinity. So it will be e to the power minus 0 is 1. Okay. Uh,
Okay.
e to the power minus infinity. So it will be e to the power infinity. So it is 0. So it is 0 by 1 plus 0. So it should be 0. Okay.
Okay.
And the reverse case, t tends to infinity means beta tends to 0. So again,
0.
P1 will be e to the power minus. This formula is general.
Yes.
So when
It's
it
1
will
over
be
2.
1, yes. So it will be the answer. Okay. Question number 12. For a system with three equally spaced energy levels or states, no, level, these are not same. states the population, again the same question, population of the highest energy state at t tends to 0 and infinity. Same question. Let's say 0, epsilon to epsilon. So when again t tends to 0, you know, at t tends to 0, only the ground state will be occupied. So eventually here will be no population. So we can write it. Highest excited state P2 will be 0. And when t tends to infinite, all state will be equally filled. So P2 will be, population will be 1 by 3. So it will be 0.33. Okay.
Okay.
But you have to keep in mind that this is not the population. Okay. Last day I also discussed this is fractional population, you can say, or you can say the
Probability.
probability. Yes, the right word is probability. So when you have to calculate the population, you have to N2, that will be capital N into P2. Then you can consider, because you know that means if there is only one particle, then 0.33%, that means 33% is the probability to occupy in the second excited level. So that is called fractional population. But here you can't calculate the original absolute population. For that you need the capital N. Then only you can do. Okay. So now we have to go our questions now. Question number 13. Okay. 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 Let me start with the residual entropy question. One. The question is, find the residual entropy for following molecules. Those are carbon monoxide, CO, next benzene, next 1,4-difluorobenzene, and 1,6-difluorobenzene. No, 1, 2. Wow. How 1, 6 it can be. So I think from here it will be clear, the residual entropy. Take any molecule, okay, any system. There are lots of 1 mole, let's say any number of molecules are there. So if you start for any temperature, T equals to, let's say, room temperature 300 Kelvin. So when you decrease the temperature, you make cooling. What will occur? First, if it is a gaseous molecule, then it will be, first it will be liquefied. Then it will be solidified. Okay, you know this. What is happening? Okay. So now when, it's not anything, 1 unit. Hmm. Yes, yes, yes. Okay, so now let's say there are n number of molecules. So when T approaches tends to infinity, sorry, 0, not infinity, 0 Kelvin means minus 273 degrees centigrade, which we know the absolute temperature. Okay, means you can't decrease temperature anymore. This is the absolute temperature, lowest temperature ever. So now residual entropy means, let's say you have taken carbon monoxide, because the first question was, so CO gas is there, carbon monoxide gas is there. Now you are decreasing the temperature. First CO, carbon monoxide gas will be liquefied and then it will be solidified. Okay. If you have any question, you doubt, you can ask me. Okay. This is very important, crucial thing. So you know what is the third law of thermodynamics? Third law of thermodynamics says that at absolute zero temperature, when T is absolute zero, then for a perfectly crystalline solid, two terms are very important. Perfectly and crystalline. Solid, it will be anyway solid. Perfectly crystalline solid, the entropy will be zero. Residual entropy will be zero. Otherwise, for every cases, there will be entropy. So now how you can do it? As I mentioned that, as I mentioned that when at very low temperature, only vibrational energy levels will be vibrational energy state will be there. You have to consider all energy state will be there, but at 0 point energy, at that T tends to zero temperature, only the 0 point energy of vibrational energy level you have to consider, because that is not zero. Other energy levels are essentially zero. But for vibrational case, that is non-zero. So only at absolute zero temperature, there you have to first consider these are solid. Solid means all are packed, tightly packed. You remember that when you are consider gas, you have to consider the rotation, vibration, translation, everything. You have studied the equipartition.
Yes.
Yes, but the term was equipartition of gas, because only gas, in case of gas you have translational motion, rotational motion, vibrational motion, all sorts of motion will be there. When you solidify, translational motion will not be there, rotational motion will not be there, only vibrational motion will be there. So only v will in a vibrational state you have to consider, other motion will be zero. Okay, so now when you are now you are decreasing temperature. So when you decrease temperature, essentially what will happen? The vibration will be less. Vibration is less means, if you look at the curve, these are vibration energy levels. What does it mean? It means that this in that energy level the molecule vibrate this much vibration is there. You decrease the energies, the vibration energy level, the vibration is decreasing. In each cases the vibration is decreasing. You have to keep in mind, if you remember, that's why this is, you have to understand this very carefully. This is a 0 point energy. But if you remember, for energy level, this is half h cross omega. This is 3 by 2 h cross omega. After that, 5 by 2, 7 by 2, and every, this omega will be. But if you look at for any energy level, you can pick up the e omega, en will be n plus half h cross omega. This is general formula. But see, for every energy level, it may be 1, E2, E0, anything, the omega is same. Omega is not changing. Omega means the angular frequency or the frequency. Frequency means number of vibration per second. That is not changing. So a molecule that may be E0 in the zeroth state, or maybe one state, second state, third state, any state it may be there. Number of vibration will be same. Let's say if it is 5 in ground state, the molecule does that molecule will vibrate 5 times in a second. In the excited state, that will again vibrate 5 times. But here the displacement is much. This much displacement is in this state, but here the displacement is this much. That's why the more energy is required in this case. And as an artifact, the energy is increasing. But in case of T tends to zero, obviously 0 point energy will be there. Other every energy level will be empty. So that's why you have to consider only 0 point energy level. And that energy, so when only 0 point energy level is considered, you know that that partition function Q. What will be Q? You know the formula of Q, that is sum over J, I or J, e to the power minus beta epsilon j. That is, this is true for each and every mode. It may be vibrational, rotational, translation, each cases. And only ground when T tends to zero, you know this. T tends to zero means beta tends to infinity, and beta tends to infinity means only G0 will be there. If you write it, let me write G0 e to the power minus beta epsilon 0 plus sum over j equals to 1 to infinity Gj e to the power minus beta epsilon j. For each cases here, epsilon j can't be 0. So beta is infinity. So e to the power minus infinity, every term will be vanished and it will be 0. So q will be g0 e to the power minus beta epsilon 0. Okay. Now, if you calculate for rotation, vibration, and translation, for translational, it is g0 e to the power minus beta 0. Okay. So it is 1 because g0 is 1 for translational case. Okay. Right? Q rotational, then similarly it will be 1. But if you see Q vibrational, it will be z0 is 1, so e to the power minus beta. But this epsilon 0 is not 0 here, it is half h cross omega. So it is e to the power minus beta h cross omega by 2. This is QV. Okay, if this is QV, then you can calculate the P. P will be e to the power minus Pj will be e to the power minus beta epsilon j divided by Q. For each cases, rotational, vibrational, for each cases you can calculate. So now let's say for rotational or vibrational, if it as it is 1, so you can write it direct e to the power minus beta epsilon j, it will be Pj. So you can see only the ground state will be populated for each cases. It may be rotational, maybe vibrational. For each cases, only the ground state will be populated. Is it understandable? When Pj is not equals to 1, beta is what? Beta is infinity. So it will be, the numerator will be 0, so P will be 0. But for ground state only, if you calculate P0, what will be P0? This will be P0. Let me calculate for translational. It will be e to the power minus beta into 0 divided by 1. So it is 1 by 1, 1. Rotational also it will be 1. For vibrational, e to the power minus beta h cross by 2 divided by same e to the power minus beta h cross by 2. So it will be 1. So it may be rotational, maybe vibrational, maybe translational. The ground state will be populated. You know that. This also already we have discussed. Other state will be 0. So what will be the orientation, arrangement? Only this state is populated, right? So when
Yes,
only this state is populated, so how many arrangements will be there? So you can write
only
it.
one.
Yes, means ni equals to n, and other ni where I not equals to sorry n0 0, it is 0. So w will be n factorial divided by n factorial. If you write it, so only one arrangement is there. You don't need formulas even. You can see only ground state is populated. So w should be 1. So only one arrangement is there. So if only one arrangement is there, so entropy will be, this is the formula kb ln w. This formula already derived in the class. So just put it. So kb ln1 and ln1 is 0. So it is 0. So there will be no entropy. Now you can think physically. If only the ground state is populated, there is no other option. What does temperature means basically? Temperature means the distribution. You have studied the kinetic, what was the chapter in, I know, Maxwell distribution. Yes, Maxwell distribution. So that also means the distribution. If you have temperature, non-zero temperature, that means you will have a distribution. Here there no distribution. All energy levels are vacant. Only the ground state is occupied. That means there is no distribution. So essentially the temperature is 0. So you can think like the definition of 0 and infinity like this. This is the proper definition of 0 and infinity in our physical universe. 0 means there is no choice. There is only the ground state will be occupied for any cases you can think. And infinite means all states are treated equally, will be treated equally. That is definition of infinite. Means if you have infinite temperature, the probability of occupying the fourth state is equals to the probability of occupying 1000 state, equals to the 0. Each state have the same probability to be occupied. That is the definition of that infinite. Just you can think like that. You have an infinite amount of money. That means you have liability to buy a mobile or anything which costs 10,000 or which costs 10 crore. Everything is equal, the probability. That is the definition of infinite. And you have zero money means you can't buy anything. All probability is 0.
Yes.
Just you can think like in terms of energy levels. That is the definition of zero and infinity. Here is also the same thing. So that's why for perfectly crystalline solid, this is the zero. Okay, but if it is not perfectly crystalline solid, then you will have the arrangements. That arrangements you have to take care. Let's consider the CO. That's and how that arrangement is generated. There is no vibrational arrangement, there is no rotational arrangement, there is no translational. All energy levels, only ground state is filled. So how the arrangement is coming? From where the arrangement is coming? That arrangement is coming due to the orientation of that molecule. Okay, so only one thing is left, that is orientation. Orientation is left. Orientational arrangement is left. So that we have to consider. That may give a
Vibrational energy?
vibration will contribute in energy, but in entropy there will be no contribution because arrangement is only one. Okay, this is
Okay.
in vibration the capital E will be n into number of molecule into half h plus omega. For other it will be zero, but vibration there is energy. But the contribution to the partition contribution to the W, that is not there because in vibration case also the ground state is only field. That has the energy, I agree, but there is no other arrangement. Arrangement is only one.
Yes, yes.
So contribution to entropy is zero. But we have to consider one more thing, that is called orientation arrangement, that comes due to the orientation of that molecule, that actually comes due to the existence of that molecule. So that we have to account, and that may contribute to entropy, contribute in entropy. How? Let me consider the CO first. First, you have to consider T tends to zero, means it can't be rotated. It can't be vibrated. Bond will not vibrate. The molecule will not rotate. Anything will not be there. Okay. In that case, you have to consider. Okay. So now CO. So first, let's say oxygen or hydrogen. In oxygen, this is. So any other arrangement is possible for oxygen.
No.
No arrangement is possible. So that's why, let me change the color. So W from this orientation arrangement is also 1. So entropy will be 0. And for every perfectly crystalline solid, I repeat, every perfectly crystalline solid, this W will be 1. No orientation will be possible. Okay. But for if it is not perfectly crystalline solid, orientation we have to consider. Let's say CO. Any other orientation is possible?
One more is possible.
Like,
Oxygen on the left side.
yes, this orientation is also possible. One may ask, this may be possible. This is not possible because this is just upside down. The box was like this, you have just rotate the box from outside, then it will be just shifted from left to right to up and down.
Why it's
Means,
not possible? It's in 3 dimension.
no, it's 3 dimension. Let's say you have a box of CO molecule like this. Let's say all are like this or this. Now if you just rotate the box, what will occur? What will be like this now? OC. So this is not a new arrangement. This is not a new arrangement. Same
Yes,
arrangement.
but along with that, in the first case, if
Hmm,
one is up down,
one is up down means
in the first case, if
oxygen.
five, yes, yes, carbon is
Huh?
up and oxygen is down in the first box, along with five in the left right.
Okay. You are saying,
Yes.
1 minute. Somebody has 1 minute. Let me connect it. Mhm. Okay. Okay, you are saying this case. Okay, but this is not a orientation.
Why?
Okay. No, no, means from you have to think from the spatial means I want to okay, okay, let me just consider that this CO. Okay. In that case, the you are changing the molecule. You can't rotate. You have to understand, na? Here you are rotating. When you are making this is just a rotation of the molecule. This is not due to a existence, due to the orientation. It's also orientation, but this orientation is coming from the uh, whole molecule. You have to take the whole molecule and you have to rotate. Here you see,
Yes, yes,
I am not rotating. I am exchanging the molecules. I am
yes,
replacing carbon
understand.
with oxygen and oxygen with the carbon. This also become generated by 180-degree rotation, but I am not giving that. That is not considered here. But how you can generate this from this by just changing the molecules? That is not possible. Now that is a rotation, pure rotation. That will come due to rotation. Later you will understand again when you consider the other examples. So you have to consider you can't give rotation, can't give vibration, anything you can't. Otherwise, you can also think this may be another orientation. Yes, but in that case, you are considering the vibrational. That you can't consider. So here it will be S equal to KBlN 2.
K will into.
Yeah. And this is for only one molecule. For 1 mole of molecule, you have to multiply it with Na, so it will be RlN2. This is for 1 mole. Next molecule is benzene. So what will be the number of orientation for benzene?
Only one.
Only one, because you have to consider this structure. So only one. Anything is not possible. You can think any orientation is not possible. So only one orientation is possible. So W is 1. So it will be 0. Let me write the hydrogens as
Its
well
entropy is zero.
at absolute 0.
And what is meant by perfectly crystalline?
Perfectly crystalline means that should not have any orientational alignment if you think in terms of statistical mechanics. But if you think like a solid state physics, then you have to think like that.
Yes, solid.
Yes, you have to go on through the definition of crystal. In crystal, what happens is in solid state, uh, structure is formed. There will be such pattern when you arrange these things. I drawn here, not like this. There should be a structure. A pattern will be carried forward in case of crystalline solid. That will give you that crystal structure. In case of amorphous solid, there is no such pattern. In diamond, you study in diamond structure like carbon. I forgot actually how it looks.
Yes,
Yes, tetrahedral. Tetrahedral carbon structure is carried forward like this, right?
yes.
So there is a pattern that will give a specific arrangement to that solid, which is called crystalline solid. So now, if there is a perfect pattern, particular pattern, you can't make molecule, you can't change or replace the molecule. Only one pattern is allowed, right? So that's why only one arrangement will be allowed. And if only one arrangement will allow, then W is 1 and the entropy will be 0. That's why you have to consider perfectly crystalline. Now, if it is not perfectly crystalline, it is crystalline. There is arrangement, perfect arrangement, but that is not perfectly crystallized. It means there is a hole or there is a defect. So in that case, if now there will be some other arrangement will be possible. So in that case, the entropy will not be zero. Okay, now 1,4-difluorobenzene. How 1,4-difluorobenzene looks? One
Para.
para. 1,4-difluorobenzene. So now how many arrangement will be there? Let me
3.
draw. Okay, let me draw. This is possible.
Yes.
Just you see, I'm not rotating. If you give a 6-degree rotation, it will be there. But I am not rotating. I am
Yes.
just replacing the molecule. You can't give rotation. Any other?
3.
If you change again
No.
there, this will be generated. So only three possibles orientation are there. So W is 3 and entropy will be KB ln 3.
KLN3.
Better you should say KB because K is a constant, but KB is essentially for Boltzmann constant. So it's better to consider the KB suffix B. Now you do 1,2-difluorobenzene
Ortho.
ortho. Now how many arrangement will be there? Just take the possible orientations.
Six arrangements.
Not two more possible, right? Yes. So six arrangements will be there. So six orientation. So W should be 6 and the entropy is
KBLN6.
6. Okay. So I think residual entropy is clear now. If there is any doubt, you can ask. Or you can think for other molecules as well. But it's clear for homonuclear diatomic molecule, it should be 0. Entropy should be 0. H2, N2,
Please repeat, your
O2.
voice was not clear.
Homonuclear diatomic molecule like H2. This is diatomic molecule, but homonuclear. Both are hydrogen for N2,
Yes.
O2. These are called homonuclear diatomic molecule. In rotational, when you study the rotational partition function, there are two classification: a homonuclear diatomic molecule and rest heteronuclear. So, for homonuclear diatomic molecule, there will be a special contribution. We'll study that later. That's why I said here. Okay. So now question number 14, I guess. Yes. From this the question, the number of configuration, this was asked in gate, I think was in the most probable state according to Boltzmann formula. Options are What will be the answer?
C.
C. How?
Similar to the energy expression.
Similar to the energy expression in partition function.
Yes.
But they ask the number of configuration. Number of configuration means W. You have to calculate the W. This is the weight factor or microstate, whatever you want to say. Number of arrangement, number of configuration.
Boltzmann means indistinguishable.
Boltzmann means Maxwell-Boltzmann distribution. That means they are distinguishable, not indistinguishable. Distinguishable.
Sorry, yes, indistinguishable.
It's not related with that even. It's very straightforward. Just you know that S equal to KBL and W. This is true for
Yes,
everything always, no? This is true. Okay. So if this is the KBL and W, then W will be L and W will be S by
S
KB.
by KB.
So W is e to the power minus S by KB, not minus plus.
E to the power S by KB. Oh, very easy.
Hmm. But just you have to think because there is only entropy is related with W directly. Directly entropy is related
Yes.
with W. Other not energy, not Gibbs energy, nothing. Okay. Next question. Question number 50. No, this question was okay. The molecular partition function of a system is given by where the oh these are symbols you know. Now that's the heat capacity. Partition function is given and we have to calculate the heat capacity.
dln q by dt.
dln q by dt, yes. That dln q by dt, what is that? dln q by dt, that is not the heat capacity. Let me go step by step. What is the CV? They ask CV, heat capacity at constant volume. That
Del
means
u del tv.
del U del TV. So you first calculate the U, internal energy. So here we will consider U equals to this. Okay, because you see this is translational partition function. Nothing is related to our ground 0 point energy. That is there. That is there, but we are just dealing with the translational part. So it's irrelevant to consider U zero or not. So U is del average of E. And the average of E, what will be the average of E?
summation NIEI.
Summation? No, that is not average of E. That is totally. You can think like this: n into small n.
Yes,
N is the total number of molecule, uh, and average. This is for one molecule or one particle, and this is for total system. So we have studied only up now till now we have studied only the molecular partition function. We did not study the this is for system. For system also you can calculate the partition function, canonical partition function, grand canonical partition function. That will be discussed in the next week, probably next week. So but till now we have studied the molecular partition function. For molecular partition function you have to calculate the totally, then you have to multiply it with the capital N directly. But this formula is only valid for canonical partition function, okay, not other. I'm just writing. Generally we use this, but this is valid for canonical partition function. Just we have to multiply the n. For grand canonical, this n is not fixed. N is also changing. So in that case, when n is also changing, you have to calculate. You have to write in like this. Both you have to consider, no? Okay. So here n is fixed. So now for one molecule, you know what is the average. KBT square DLNQ dt.
yes, that was actually.
This is for one molecule. Now you know the Q. What is Q? Q is given as KBT divided by HC to the power 3 by 2 and 8 pi square M KBT by H square to the power 3 by 2. Okay. Anyone is showing my screen? Okay. So this is the case. Oh, here you can see mm, this is coming from translational part, but this is not from translational part. Okay, from where
Yes,
it is coming? Don't know. It is just given. It's just function of temperature. That's it. So just you can bring the temperature out. So it's T3,
but it's
and
not the correct expression for the partition function.
why? Why?
2 pi m kbt by square whole 3 by 2.
No, this is not for translational. Who have said you that this is for translation? Translation. This is total partition function, and total partition function is the product of the all partition function. Maybe due to product q rotational into q vibrational q translational, and after taking approximation this partition function appears somehow.
Okay,
Okay, because you see this part kbt by hc, this type of part appears in vibrational partition function e to the power something, so probably they have taken the approximation, but this is given to you. That's not our business here. So let's say this is just t cube into a constant. Why I'm saying constant? Because that is not a function of temperature, rest of the part.
yes,
Now you have because you have to take the derivative with respect to only our
temperature.
temperature, so that is irrelevant. So now ln q will be 3 into ln q plus ln c. So as ln c is constant, so ln c will also be constant. So dln q dt will be 3 by t plus 0. So just 3 by t dln q dt.
Yes,
So what will be the small e average kb square into 3 by
3 by
t.
t.
So it is 3 kb, 3 kbt. Okay. So what will be capital E? 3n kbt. And Cv will be Del U del E del T V, because U is this
3 in kb.
3 n kb, and we know this is the answer 3 n kb. This should be the answer. Now, for 1 mole CVM, if you consider, then N equal to Na, that is 3R.
Yes,
So from here, what is what conclusion you can make?
it is not dependent on the number of molecules.
No, it's dependent. N is there.
Temperature.
Temperature, how can we? You have taken the derivative with respect to temperature. After that, from where temperature dependence will come. From here, you can say this is actually a translational partition function. Vibrational notation is not there.
How?
Our thought was wrong because only 3R is coming. You know how 3R okay, no. If you consider no, okay, then we can. What is the U for if you consider only translational? 3 by 2 kT, right?
Yes.
Okay, okay. So no, then that means there is another. Yes, we are right. There is another contribution as well, because if it is only translational, I wrong because it is CR. So then, if it is only translational, then CV will be 3 by 2 and CVM
K.
3 by 2 R, but it is 3R. So it is not only the translational. There are other modes also considered. When all the partition function will be discussed, rotational, vibrational, electronic, then we will discuss such type of problems considering all molecules. Then you have to consider the equipartition principle as well. Using those, you have to calculate the total Q, and then you have to calculate the total partition function. Here, the total Q is already given to you. So here, not only translational is considered. You see, if only this part is considered, then it will give you T to the power 3 by 2, and the overall CVM will be 3 by 2R. So this part is coming from the translational
Yes.
surely, UP, but this is coming from somewhere else. Okay, that is not from the
If
translational.
it's 3 by 2R, then I can say it's translational.
Exactly, if it is 3 by 2R. Because translational will be there. After that, rotational may be there, vibrational may be there, translational will be there always, because that costs least amount of energy. That mode
2
will be there.
translational make 3R.
Two translational makes 3R means
3R by 2 plus 3R by 2.
how two translational will be there. Translational has only 3 degrees of freedom, so it will be always 3 by 2R.
Okay. Yes.
Each degree of freedom consists half kBT energy, so 3 mode will be 3
Yes.
by 2 kBT. So if it is only a monoatomic gas, then also it is 3 by 2 kBT. If it is diatomic, then there will be rotational degrees of freedom as well, vibrational degrees of freedom as well. But when you are considering solid, because we know these are for gas, heat capacity, these things, all for gases. Okay, not for the solid. In case of solid,
Yes.
there is no rotational degrees of freedom. There is no vibrational, translational degrees of freedom. Only vibrational degrees of freedom will be
Vibration.
there. So that you have to understand from the question. Okay, so any question? Okay, one more question we can discuss, but this is a long question. We should not discuss this question. Let me check any other. Okay, this question we can discuss. Question number 60. Consider a system of n number of non-interacting indistinguishable particles, where each particle can be in three energy levels only. The lowest one called the ground state, is degenerate, non-degenerate, and its energy is considered to be zero. Just they have written in words. The middle one at energy epsilon and W is degenerate. The highest one at energy 2 epsilon and triply degenerate. Calculate U and S. For today's class, we'll discuss only U. Calculate U. Next class, we'll start from the same question and we'll discuss the entropy. Because the entropy formula we also discussed in class, but okay, we'll discuss again. So calculate the U. So U means daily. Here we have considering daily equals to U. Not daily, average of U, sorry. So now there are three energy levels. First one is non-degenerate, second one is doubly, third one is triply. And energy is 0, epsilon, 2 epsilon. So what is the partition function? Q partition function will be, we know, sum over g I e to the power minus beta epsilon I. So it will be 1
G0.
plus 2 into the power minus beta epsilon plus 3 into the power minus 2 beta epsilon.
Yes.
Correct? So this is now what will be our small e? It is kbt square
D ln
dln
Q dt.
q dt. But in terms of beta, you can also write. What will be in terms of beta? 1 by q dq del beta. In this equation, if you put beta equals to 1 by kbt, then you will obtain kbt square dln q dt. This is the first equation. You can do it easily. You know the q. You know q, right? So from q, when you q is sum over j to the power minus beta epsilon j. Correct?
Yes.
When you make differentiate with beta, what will you get? Let g is not there. Then when what will you get? Epsilon j
E to the power minus beta
minus
epsilon
beta
j.
e minus beta epsilon j, and minus term will be there. So you can write it like this. Okay? Is it okay?
Okay.
Hello? Now let's say if you consider which we know that this is actually pj,
Yes.
and pj is e to the power minus beta ej divided by q, and correct.
Yes.
So from here you can write del q del beta equals to q into this. So now if you put it, then you can write. Okay. And
Okay.
why the volume is there, volume is constant, from where the volume is coming? If you want to understand this, you have to wait for canonical ensemble. Okay, there it will be discussed.
It's not as same as chemical thermodynamics.
No. From here, anything volume is this related to volume is discussed till now. No volume was there. So suddenly how
Yes.
the volume has came. Okay. Actually, what happens, these energy levels, E, these energy levels are actually function of N, V, E for canonical ensemble. Okay. And you are change, N is constant, V is constant, only T is changing. That's why you have to give V here. Okay. It will be discussed
Okay.
in canonical ensemble. Okay, so this is the capital E. Now from here, if you put it del Q del beta, what will be del Q del beta? Let me write. Del Q del beta will be 0 plus, not plus, minus 2 epsilon e to the power minus beta e plus, no plus, again minus 6
Minus
epsilon,
3 epsilon. Yes,
e,
sorry, 6 epsilon.
6 epsilon to beta e. So minus 2 epsilon common e to the power minus beta e plus 3 e to the power minus
2 beta
2 beta
epsilon.
e. Yes. So this will be minus minus will be cancelled. So it will be 2 epsilon e to the power minus beta e plus 3 into e to the power minus 2 beta e. In denominator there will be q, and q is just 1 plus e to the power minus into epsilon plus. Okay. So this is the capital E, small e. And what will be the capital E? Just you have to multiply it with n. Okay.
Okay.
Okay. So again, further, if you have any question, you can ask me. And the entropic part we will discuss in the next class.
Is there any question remaining?
From the assignment,
Yes.
no. But
No, your questions.
yes,
This.
my question remaining. I prepared almost 10 questions, but just we discussed 3 to 4. In next class, we will
Will you
discuss.
give it on the PDF or?
No, no, we'll discuss it. Next class, we will
Okay.
discuss. Don't worry. I
And
have
what
prepared.
about the notes
Notes I have uploaded in the
in the
Drive.
PDF?
Yes, in the Drive link, I uploaded the statistical thermodynamics notes.
Okay.
You can check. I have uploaded.
Okay. Thank you.
Okay. So now let me stop sharing first. Okay. So if you any message was there. Okay. Pritam, you can say even don't because while sharing the screen, I can't see the messages. Okay, that's why you said something. But Ovilasha also asked. Okay, then he asked even that question. Okay, don't need to write. You can directly unmute and you can ask. Okay. So if there is no question, we can we'll meet again in next Sunday at 4 p.m. Okay, Pritam. Okay, then we can leave again.